Hey, welcome back everyone. Happy New Year, and we're back on Project Streamliner. I apologize, it's been a while since the last video, but progress has been very slow, and as much as I was having fun doing hundreds of reprints, I think that it didn't make for very good YouTube material. So I realized that since part 3 that I've really over-engineered this for a 1.0 design. Realistically, I should have started out with a much smaller scope and testing individual components and systems and parts. I spent a lot of time trying to integrate all the systems into this body shape, which ultimately was all dependent upon whether or not this single wheel setup and these two front wheels were going to actually work. So to get back on the right track, my main focus has shifted from trying to integrate everything into this tight little body shell to actually let's test out the parts and pieces of this overall system, even without the nose and the tail and everything, just to see if we can actually get it to drive decently. I don't know if you can see that in there, but that is a 2812 1115 kV brushless outrunner motor that's capable of a little over 1500 watts of power. And I'm running it on a 3S LiPo for all of these tests. I'm actually not going to be running any shocks, and I don't have any gyro stabilization or microcontrollers integrated yet. And as you'll see in the testing, that's definitely a must-have for a high-speed type car like this. So let's go ahead and give this thing a run. Pavement's much smoother on this side. I'm going to try it on this side, but it seems to handle the bumps really well once it gets going. Yeah. For the second run here, I've increased the expo a lot on the steering and the throttle, and then actually limited the steering down to about 50% range. Oh yeah. Wow. Yeah, without a gyro, this is going to end up every time rolling over as soon as you get on the gas. Needs traction control, etc., etc. It's taken the abuse fairly well. I mean, it slid. That last time was probably real close to 45 mile an hour, and it was sliding on its side to stop. So definitely going to probably wear through the main body tube before I break it. This is a good location though. There's literally nothing to hit, and even if I do high-speed runs, I'll actually run into a giant embankment of dirt if something goes wrong. So as you saw there in the testing videos, I think overall that was a very successful test. A lot of the major systems were working really well. Once I got the steering trimmed in and really got the expo and set the dual rates on the steering, I think that was in a really good place. The throttle is obviously going to be an issue. this is just something that happens with brushless, sensorless motors, is that it has to generate enough back EMF, essentially enough load, to be able to measure the position of the different phases of the motor, which means essentially it has a minimum speed that it's going to be able to spin. And as you can see, as soon as you just hit that minimum speed, it blows the tire off the rear. Obviously, the motor is more than strong enough to move the car from a standstill, which is a concern I had. A lot of people were telling me that I would need like a 300 or a 400 kV motor to be able to do a hub motor, and that's definitely not the case at all. Acceleration in general is extremely fast, which is good. It definitely had the performance that I was looking for. I mean, you know, with 1500 watts of power, and this is about 1.1 pounds, or I think just over 500 grams or something like that. That's a pretty light car to be accelerating with that much power. Again, the steering worked really well. As I planned, I was able to actually, you can't really see it here, but I was able to shim the steering rack with a washer so that I could get the tolerances between the rack and the pinion to be extremely tight so that I didn't have any play. It's very durable. You know, as you could see from the first day of testing there, it withstood multiple front end impacts with the curb directly. It's relatively well dampened. I think there's a good bit of friction in the suspension joints themselves. I definitely can add more dampening, particularly on the rear, so that we can get less wheel hop. But I think a lot of that's actually due to, as I talk later, the unsprung weight that we're dealing with here. And the other good thing about all this is that the motor, despite running it for over an hour of stop and go, was ice cold the whole time. It didn't melt the PLA, and the ESC, which is overrated here, an 80 amp ESC, was very cold the whole time as well. Of course, it was about 30 degrees Fahrenheit. I don't know what that is, about -1 or 2 centigrade. So it was very cold outside. So actually, I think that was actually contributing to the lack of traction that I was having. I think as you saw from the videos, the car spins out extremely easily, particularly when launching. I would say probably only 1 out of every 5 launches actually succeeded in getting up to the speed required to keep the car moving. And I think that's due to the fact that you have to essentially get the motor spinning fast enough for the gyroscopic effect to stabilize it, as well as I think there's some misalignments in the suspension itself. I need to go through and essentially make an alignment jig for this because if you noticed, it always spun out to the left. This wasn't something I really noticed until I started pulling all the footage together for the video here. I was like, oh, wow, it's always left. So I think I may have to either line up the center of the mass that's actually spinning better on the center line, or, I did some measurements here, and I think the tire might be about 1 millimeter off. It's very difficult to control the wheel spin. So I think that this definitely needs stability control, and that was my plan the entire time. I'm going to have an MPU 6050 integrated with a microcontroller up front here to provide gyroscopic stability so that I can counter steer with the front tires, as well as I'll set essentially a maximum acceleration rate, so the maximum number, like a maximum G load that I feel that the tire can always give me, so that it won't be able to spin out. Later on, I might get more sophisticated and actually put a Hall sensor in here so that I can, set it to have a certain amount of slippage so that I can maximize my acceleration. Okay, so as far as suspension, I think overall it was pretty good. The spring rates could definitely be optimized a bit more, but I've got bigger issues that I need to kind of work through. The front spring rate's a little too high. It definitely needs dampers. I'm going to probably initially just start off with some standard 3D printed dampers and try to get the valving where I want it, so I can kind of get a feel for how the dampers are going to make this thing act. So I did the weight distribution of the car here, and the front is 233 grams and the rear is right at 300 grams. But what's unique about that is almost 70, or actually almost 80 grams of that rear weight is just this wheel and the motor. So you have a huge amount of unsprung mass. So where that complicates things is where you saw in the videos, you would actually see it do a huge amount of wheel hop as it took off. And this is, I believe, due to a few reasons. One, this tire is very low profile, and it's not giving very much spring. And this plastic, the PLA here, is obviously way over engineered and too heavy. So it has no flexibility whatsoever. So what was happening is essentially the tire was skipping across the surface. The other thing that made this difficult was that I think I had too much rear spring rate. So the spring rate here needs to be much lower, but at the same time it has to be able to resist the torque of the motor from being able to flex it too much. So it's definitely a complicated thing. I think that's where I have to have the damper in there to be able to absorb that initial impact from acceleration while being able to have a lower spring rate. The other thing I'm going to do is, of course, increase the sidewall significantly of my next tire design. And I may actually use rubber for the outside layer, and then have a layer of TPU, and then I'm most likely going to reprint this out of nylon, which was always my initial plan. I'm going to make it much more flexible and kind of almost go along the lines of a tweel, which is kind of what Michelin has with the airless tire. And that I'll make these spokes flexible, so they'll only be probably like 0.8 millimeters in thickness. That's going to do two things. One, it's going to make the whole tire and wheel assembly more flexible. The plastic has a self-dampening property to it, which is going to be really good for the fact that I have all this, mass that I have to figure out how to dampen. Nylon is going to be very impact resistant, but at the same time, the lighter I make this, the less centrifugal force I'm having to deal with shredding the whole thing. Now the tire does look pretty bad on the rear, but that's because, as I said, it always would pull to the left and fall down on this side. As you can see, this side of the tire is perfect. Okay, well, I think that wraps it up for this video. As you can see, I've got a long laundry list of things that I need to work out. Like I said, my plan is to hopefully get the new rear wheel designed and printed, and then also get some sort of shock absorbers integrated into the car so that I can actually start doing some dampening tests, and then hopefully do another round of testing with just the different rear wheel designs and the dampening. I'm really excited about this. I really want to get the microcontroller in here, stick an SD card in it so that I can log all of the data. I'll have, all the servo angles, all the motor data, voltages, temperatures, the gyro data, the GPS data, all that stuff being able to be pulled together so I can really figure out, what's going on with the car. But that's all for a future date. Thank you all for watching, and stay safe out there. Bye.